In Module 5 of Chapter 24, we're going to look at the first of two modules on a binomial interest rate pricing structure. And this will be reminiscent of the binomial pricing structures we looked at for stocks. And many of the calculations we do will be reminiscent of those we've studied earlier. So binomial interest rate models permit interest rates to move randomly over time and have many of the same properties as a binomial stock price model. We need a period of time for the length of the binomial period. Again, we'll denote it by H. And in a figure we're going to look at in a moment, there's an assumed H of 1. So we'll need to keep that in mind, that in some of the formulas based on that exemplified lattice, H is 1. And in general lattices where H is not 1, we'll need to make an adjustment in the formulas, and I'll bring that up later. So we'll let some common notation, R at T sub 0 is a forward interest rate. So this terminology or this notation is similar to what we've seen before. It's the forward rate as of time T0 for interest between time little t and time capital T. Because at time little t, in a binomial lattice there will be several states, we need to have a somewhat more complicated, a somewhat richer notational structure. And so we're going to use this notation here where we add an additional parameter j to say this is the spot rate between time little t and time capital T in state J. So again, we're still at time 0. You can think of this that we're at time T0, and we have different forward rates between time little t and time capital T, depending on which state we're projecting in our binomial lattice. You can imagine that there would be low interest rate states at time little t and high interest rate states at time little t, and at time T0 in our lattice we can observe what those states are, and we'll call them with a letter J. So at any point in time, T0, which is typically time 0 today, we can have in our lattice the development of various interest rates as they emerge over time. And it's very common that the interest rates that emerge will be annualized interest rates, even if H is less than 1. And that will affect the way the formulas appear, and I'll point this out as we go there. We also need a risk-neutral probability, and we'll just let P, we could use P star, but P here should not cause confusion. We mean P here to be the equivalent of the P star in the stock chapters. It's the risk-neutral probability of an upstate. So here's an example of a tree with H of 1. And what we have here is R0, and notice down here I added some notation to connect this notation with the notation I just introduced. And that is that if we look at, for example, this term here, this is a rate between time 2 and time 3 in state 1. So the state is, this is state 0, state 1, state 2, state 3. But each one of these interest rates is a forward rate from time 0's perspective, and the forward rate that applies from time t, 2 to time 3. So R00 goes from time 0 to time 1. R1, the next one goes from time 1 to time 2. In fact, I like to draw binomial lattices as follows. I personally don't like this notational structure for interest rate lattices because it's reminiscent of a stock lattice, and it's quite different than a stock lattice. In a stock lattice, the value at time 0 is the price at time 0. It has no future value. However, the price at time 0 of R, I like to draw a lattice without the diagonal bars and just draw it as a series of horizontal bars. And in this notation, it's much more suggestive that R0 applies to the interval 0, 1. The next interest rate applies to the interval 1, 2. The next one applies to the interval 1, 3. In other words, I think of an interest rate as spanning a period of time over which one uses that interest rate to discount. When you put it as spot points, as is done on the stock-like lattice, it can be confusing as we start looking at some of our pricing formulas. So that when we want to price a time one cash flow, we use R00, which can look confusing, but in this notational scheme of writing the tree as all horizontal lines, it becomes quite apparent that to discount dollars from time 1 to time 0, I use the R0 value. Obviously, the notational preference, you can use either approach as long as you understand the meaning of this notation.